Myself, Amanpreet Singh, lecturer in Mechanical Engineering Department, Government Polytechnic College, Amritsar. Today my topic is cooling of IC engines. First part is introduction. In IC engines, fuel is first injected and then ignited in the engine cylinder. The ignition causes combustion. We all know that the fuel is first injected and then ignited in the engine cylinder. After ignition, the combustion takes place in the engine cylinder. During combustion, a large amount of heat is produced. So, in an IC engine, the heat energy produced is converted into the mechanical energy. We all know that by second law of thermodynamics, no heat engine can convert the whole of the heat energy into its equivalent mechanical work. So, engine can convert the no heat engine can convert the whole of the heat energy into its equivalent mechanical work. Next part is why cooling is necessary. So, in an IC engine, a large amount of heat is produced during the combustion of the fuel. So, this heat, which is produced, the only 20 to 30% of the total heat is converted into its useful work. Second, about 40% of heat is carried away by the exhaust gases. The remaining part, that is 30% of the total heat, is absorbed by the material of the cylinder and the other components of the engine. So, the energy which is produced in the engine cylinder, only 20 to 25 to 30% is converted into useful work. Next 40% is carried away by the exhaust gases, and next 30% of the total heat is absorbed by the material of the cylinder and the other components of the engine. This third part of energy, which is 30% of the total heat, which is absorbed by the material of the cylinder and the other components of the engine, should be removed or should be abstracted. Next part is, if this heat produced by the engine components is not dissipated or removed by some method of cooling, then the material of the components may even melt. ਜਿਹੜੀ એનર્ਜੀ ਇੰਜਨ ਕੰਪੋਨੈਂਟਸ ਦੇ ਵਿੱਚ ਅਬਜ਼ੋਰਬ ਹੋ ਜਾਂਦੀ ਹੈ, ਜੇ ਆਪਾਂ ਉਹਨੂੰ ਰਿਮੂਵ ਨਾ ਕਰੀਏ ਤਾਂ ਇਹ ਜਿਹੜੇ ਕੰਪੋਨੈਂਟਸ ਨੇ ਮਟੀਰੀਅਲ ਜਿਹੜਾ ਕੰਪੋਨੈਂਟਸ ਦੇ ਮਟੀਰੀਅਲ ਨੇ, ਇਹ ਈਵਨ ਮੈਲਟ ਹੋ ਸਕਦੇ ਨੇ. Therefore, it is necessary that the engine should be cooled to prevent dangerous overheating. If the engine is not cooled, the temperature will be seriously harm and the function of the engine. The valves will burn and piston will seize in the cylinder due to expansion. During combustion, a lot of heat is produced in the engine cylinder. Only some part is converted into useful work, some part is go to exhaust, and remaining 30% of the heat produced is absorbed by the engine components. So, this part which is absorbed, this part of heat which is absorbed by the engine components should be removed by any cooling method. The heat produced during the combustion can produce the temperature of near about 1500 to 2000 degree centigrade, which is very high temperature, which is equal to the melting point of the platinum. So, this extra heat which is absorbed by the engine components should be removed by any cooling method in order to prevent the dangerous overheating of the engine. Next part is functions of a cooling system. The cooling system should dissipate only that quantity of heat which is necessary, to prevent dangerous overheating of the engine. The cooling system The cooling system should dissipate only that quantity of heat which is necessary to prevent dangerous overheating of engine. Second part is the cooling system should not keep the engine cool. The only that cooling system is provided which can keep the engine at appropriate temperature. Excessive cooling does not allow the fuel to vaporize properly, thus the efficiency of the engine is decreased. We know that the efficiency of IC engine depends upon the thermal efficiency of the engine. Due to overcooling of the engine, the fuel does not vaporize properly, and so the efficiency of the engine is decreased. Third part is the cooling system should be able to control the amount of cooling under the different working conditions. Cooling system should be such that it should control the heating when the engine is at high temperature, and during the starting time it should not be cooled so much so that the engine will be cooled down. Next part is, in order to remove the heat from the various components of the engine parts, the two methods are used for the cooling. First is direct air cooling or air cooling. Second is indirect air cooling or water cooling. In air cooling, it is the simplest system that can be used for cooling of an IC engine. This system is used in motorcycles, bikes, scooters, also in aeroplanes. In this system, the heat is directly dissipated from the cylinder to the surrounding air. In this system, the heat from the different components of the engine cylinder, when come in contact with the surrounding air, the heat will transfer from the material of the cylinder to the surrounding air. In order to improve the air cooling, the fins are casted on the outer surface of the cylinder barrel and the cylinder head. These fins are provided in order to produce the to improve the surface area which will come in contact with the surrounding air, so that the rate of cooling will be increased. So in order to improve the air cooling, the fins are provided on the body of the cylinder and cylinder head. This is diagram which shows the air cooling system. This is the bore of the cylinder, and this is the cylinder fins. Fins are provided on the outer surface of the bore of cylinder. When the combustion takes place in the cylinder, we all know that a large amount of heat is produced in the cylinder. So this heat has to be removed to the surrounding. So fins are provided in order to improve the cooling rate of the engine. The advantage of the air cooling system is, first is this system is very simple in design. Second is light in weight. Third is it is very suitable in cold region where water may freeze. This system can be used at high altitudes where the temperature is very low and the water may freeze. There is no problem of corrosion. There is no wear problem in this system. The disadvantage of this system is the use of this system is limited in small engines. ਇਹ ਜਿਹੜਾ ਸਿਸਟਮ ਆ ਇਹ ਸਿਰਫ ਆਪਾਂ ਛੋਟੇ ਇੰਜਨ ਵਾਸਤੇ ਯੂਜ਼ ਕਰ ਸਕਦੇ. This system provides non-uniform cooling. Third part is the air-cooled engines are more noisy. These engines are more noisy than the water cooling system. So this system of cooling is not so much efficient as that of water cooling system, because the cooling rate of this system is not uniform. In this system, when the engine moves, the air comes in contact with the outer surface of the cylinder and the fins, outer surface of the cylinder and the fins. These fins are exposed to the atmosphere, and the heat is conducted from metal, and then it is uh, goes to the environment or air. Next part is water cooling system. In water cooling system, the heat is first transferred from various components of engine to water, and then from water to the water it is dissipated to the surrounding air. In this system, the heat which is first produced in the engine cylinder is firstly uh, removed by the water, and then from hot water then it is dissipated to the surrounding air. That is why this system is also known as indirect air cooling system. In the water cooling system, water is circulated through the water jackets. In this system, water jackets are provided around the engine cylinder and piston and other parts of the engine components as the cylinder valves. These water jackets are provided around the cylinder barrel, combustion chamber, and valves. The hot water in the water jackets is cooled down by passing it through a radiator and is recirculated. ਵਾਟਰ ਕੂਲਿੰਗ ਸਿਸਟਮ ਦੇ ਵਿੱਚ ਪਾਣੀ ਨੂੰ ਪਹਿਲਾਂ ਵਾਟਰ ਜੈਕਟਸ ਦੇ ਥਰੂ ਭੇਜਿਆ ਜਾਂਦਾ। ਇਹ ਜਿਹੜਾ ਵਾਟਰ ਹੈ ਇਹ ਇੰਜਨ ਕੰਪੋਨੈਂਟਸ ਦੇ ਵਿੱਚੋਂ ਪਾਣੀ ਲੈ ਕੇ ਹੀਟ ਲੈ ਕੇ ਤਾਂ ਉਸ ਹੀਟ ਨੂੰ ਉਸ ਵਾਟਰ ਨੂੰ ਫਿਰ ਅੱਗੇ ਰੇਡੀਏਟਰ ਦੇ ਥਰੂ ਸਰਕੂਲੇਟ ਕੀਤਾ ਜਾਂਦਾ, ਔਰ ਰੇਡੀਏਟਰ ਦੇ ਵਿੱਚ ਜਿਹੜੀ ਹੀਟ ਹੁੰਦੀ ਹੈ ਉਹਨੂੰ ਰਿਮੂਵ ਕੀਤਾ ਜਾਂਦਾ। ਨੈਕਸਟ ਪਾਰਟ ਇਜ਼ circulation of water. In water circulation, in water cooling system, the circulation of water takes place in the engine cylinder to the radiator by two methods by which the water can be made to circulate through the water jackets and the radiator. So ਦੋ ਸਿਸਟਮ ਨੇ ਜਿਸ ਨਾਲ ਪਾਣੀ ਜਿਹੜਾ ਸਰਕੂਲੇਟ ਕੀਤਾ ਜਾਂਦਾ ਰੇਡੀਏਟਰ ਤੋਂ ਡਿਫਰੈਂਟ ਪਾਰਟਸ ਆਫ ਇੰਜਨ and from different parts of engine to radiator, or with the help of jackets ਤੋਂ radiator ਦੇ ਵਿੱਚ and radiator ਤੋਂ jackets ਦੇ ਵਿੱਚ ਦੋ ਸਿਸਟਮ ਨੇ ਪਾਣੀ ਨੂੰ ਸਰਕੂਲੇਟ ਕਰਨ ਦੇ। ਪਹਿਲਾ ਫਸਟ ਸਿਸਟਮ ਇਜ਼ ਥਰਮੋਸਿਫਨ ਸਰਕੂਲੇਸ਼ਨ। ਪਹਿਲਾ ਸਿਸਟਮ ਹੈ ਉਹ ਕੀ ਹੈ, ਥਰਮੋਸਿਫਨ ਸਰਕੂਲੇਸ਼ਨ। ਇਸ ਸਿਸਟਮ ਦੇ ਵਿੱਚ ਜਿਹੜਾ ਵਾਟਰ ਫਲੋ ਕਰਦਾ ਉਹ ਡੈਂਸਿਟੀ ਡਿਫਰੈਂਸ ਕਰਕੇ ਫਲੋ ਕਰਦਾ ਫਰੋਮ ਰੇਡੀਏਟਰ ਟੂ ਵਾਟਰ ਜੈਕਟਸ ਐਂਡ ਫਰੋਮ ਵਾਟਰ ਜੈਕਟਸ ਟੂ ਰੇਡੀਏਟਰ। ਆਪਾਂ ਸਾਰੇ ਜਾਣਦੇ ਹਾਂ ਜਦੋਂ ਵੀ ਵਾਟਰ ਫਲੋ ਕਰਦਾ ਜਿਹੜਾ ਹੌਟ ਵਾਟਰ ਹੁੰਦਾ ਉਹਦੀ ਡੈਂਸਿਟੀ ਡਿਕਰੀਜ਼ ਹੋ ਜਾਂਦੀ ਅਤੇ ਕੋਲਡ ਵਾਟਰ ਦੀ ਡੈਂਸਿਟੀ ਵੱਧ ਜਾਂਦੀ। ਸੋ ਜਿਹੜਾ ਹੌਟ ਵਾਟਰ ਆ ਜਿਸ ਟਾਈਮ ਉਹਦੀ ਡੈਂਸਿਟੀ ਵੱਧ ਜਾਂਦੀ ਉਹ ਉੱਪਰ ਉੱਠਣਾ ਸ਼ੁਰੂ ਹੋ ਜਾਂਦਾ, ਲੋਅਰ ਵਾਟਰ ਨੀਚੇ ਰਹਿ ਜਾਂਦਾ। ਇਸੇ ਟਾਈਪ ਕਰਕੇ ਹੀ ਜਿਹੜੀ ਸਰਕੂਲੇਸ਼ਨ ਪ੍ਰੋਡਿਊਸ ਹੁੰਦੀ। ਸੋ in thermosiphon circulation, ਜਿਹੜਾ water is circulated by due to the density difference between the hot water and the cold water. Second part is the forced circulation. When the circulation in the system water is circulated from the radiator to the water jackets by means of a water pump. In this system, a water pump is used to circulate the water from the radiator to the water jackets and then water jackets to the radiator. The cold water comes from the radiator and then it goes to the water jackets and then after taking it heat from the engine parts, then hot water goes to the radiator. This is diagram for the thermosiphon system. In this system, this part is radiator, this is upper tank, this is lower tank, engine, lower house pipes, upper house pipes. In this system, the engine should be placed below the radiator. The hot water from the engine goes upward to the upper tank of the radiator, and from top tank hot water moves downward through the core, and in lower water, when water flows from upper tank to lower tank through cores, it dissipates its heat to the surroundings. When it comes to the lower tank, the water will be cooled, and cold water which has more density than the lower water, it comes to the engine, and hot water goes to the upper tank of the radiator. So the circulation comes place by the density difference of hot water and the cold water. We know that the density of hot water is more than the density of is less than the density of cold water. So hot water moves upward and cold water moves downward. Next part is forced circulation. In this type, the water is circulated from radiator to the engine parts with the help of an water pump. This is the water pump which can be used for circulation. In this, the cold water from the lower tank is pumped by this water pump. Water goes to engine, and water takes heat from the various parts of the engine. Then it goes to the upper house pipes of the engine and go to the upper tank of the radiator. The hot water comes through the cores. These are the cores. When the water comes from the top of the radiator to the lower tank, the cores are provided and water pass through these cores, and due to fan or when these cores are coming in contact with air, the hot water is cooled by dissipated its heat to the surrounding. So this is the forced circulation, in which the water is circulated from radiator to engine with the help of water pump. Next part is what are the various parts of water cooling system. The various parts of water cooling systems are water jackets. First is water jackets, second is radiator, third is water pump, fourth is fan, and fifth is thermostat. So first part is water jackets. Water jackets are the passes casted as an integral part of the cylinder block and the cylinder head through which the cooling water is circulated are known as water jackets. ਇਹ ਜਿਹੜੀ ਵਾਟਰ ਜੈਕਟਸ ਨੇ, ਇਹ these are the integral part, ਇਹ ਸਿਲੰਡਰ ਬਲੌਕ ਦੇ ਵਿੱਚ ਜਾਂ ਸਿਲੰਡਰ ਹੈਡ ਦੇ ਨਾਲ ਹੀ ਬਣੀਆਂ ਹੁੰਦੀਆਂ। ਇਹਦੇ ਵਿੱਚੋਂ ਜਿਹੜਾ ਆਪਾਂ ਕੂਲਿੰਗ ਵਾਟਰ ਹੈ, ਜਿਹਦੇ ਨਾਲ ਆਪਾਂ ਇੰਜਨ ਨੂੰ ਕੂਲ ਕਰਨਾ, ਇੰਜਨ ਦੀ ਹੀਟ ਨੂੰ ਰਿਮੂਵ ਕਰਨਾ, ਔਰ ਵਾਟਰ ਨੂੰ ਇਹਦੇ ਵਿੱਚੋਂ ਸਰਕੂਲੇਟ ਕੀਤਾ ਜਾਂਦਾ। ਸੋ ਦਿਸ ਵਾਟਰ ਜੈਕਟਸ ਆਰ ਪ੍ਰੋਵਾਈਡਡ ਔਨ ਦੀ ਸਿਲੰਡਰ ਹੈਡ ਐਂਡ ਆਲਸੋ ਔਨ ਦੀ ਸਿਲੰਡਰ ਬਲੌਕ। ਹਾਂਜੀ, this figure shows the water cooling system. The different parts of water cooling system are water jackets. These are the water jackets. These are the water jackets through which the cooling water circulated from the radiator to the various parts of the engine, as engine cylinder, engine head, and other parts, valves. So these are the water jackets. This is the pump, this is the radiator, water pump, fan, this is the fan, and thermostat. Thermostat is used for this is the thermostat. This is the thermostat, fan, impeller, turn house pipe, inlet house pipe, top tank, bottom tank, radiator. So these all are the various parts of the water cooling system. Next is this figure shows the cylinder block. In this is the piston and this is the cylinder. When piston moves upwards and downwards, this is the piston, this is the cylinder block. These are the water jackets. 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 So these are the water transfer ports. These are water transfer ports are provided to transport water from water jackets to the water jackets from the cylinder block to the cylinder head. This is the cylinder head. This is cylinder head. So these are the valve ports. So water jackets are provided around the cylinder block and the cylinder head. These water jackets they can dissipate heat from the engine block, engine cylinder. The heat is dissipated by the water. Then this heat is also dissipated by the from the cylinder head where the valves are placed. These are the valves ports. So water jackets are also provided here. So next part is radiator. The radiator is the component which helps in dissipation the heat from the circulated water to the air current, that is known as radiator. Radiator ਦੀ ਹੈਲਪ ਨਾਲ ਆਪਾਂ ਜਿਹੜੀ ਵਾਟਰ ਸਰਕੂਲੇਟ ਅਸੀਂ ਕਰ ਰਹੇ ਹਾਂ ਵਿਦ ਥਰੂ ਵਾਟਰ ਜੈਕਟਸ, ਉਹ ਵਾਟਰ ਨੂੰ ਸਰਕੂਲੇਟ ਕਰਕੇ ਇੰਜਨ ਦੇ ਵਿੱਚੋਂ ਫਿਰ ਉਹ ਰੇਡੀਏਟਰ ਦੇ ਵਿੱਚ ਸਰਕੂਲੇਟ ਕਰਕੇ ਟਰਾਂਸਫਰ ਕੀਤਾ ਜਾਂਦਾ ਟੂ ਦੀ ਰੇਡੀਏਟਰ। ਰੇਡੀਏਟਰ ਦੇ ਵਿੱਚ ਜਿਹੜਾ ਇਹ ਹੌਟ ਵਾਟਰ ਆ ਜਾਂਦਾ ਉਹਨੂੰ ਠੰਡਾ ਕੀਤਾ ਜਾਂਦਾ, ਕੂਲ ਕੀਤਾ ਜਾਂਦਾ। ਇਹ ਜਿਹੜਾ ਰੇਡੀਏਟਰ ਹੈ ਇਹ ਇਟ ਕੰਸਿਸਟ ਆਫ 3 ਪਾਰਟਸ। ਫਸਟ ਇਜ਼ upper tank, second is core and third is lower tank. This is the figure. This is the figure of the radiator. This is the upper tank. This is the lower tank. These are the cores. These all are the cores, and this is hot water comes from this port, enter here and goes downward. When the hot water comes here, it collects in the top tank, upper tank, and from top tank the hot water comes from upper tank to lower tank through the cores. When hot water is passed through the cores, when hot water is passed through the cores, the cooling air comes in contact with the cores, and also the small fins are provided at the cores. So due to these fins, the surface area increases of the cores, and it increases the cooling efficiency of the radiator. So when cooling air comes in contact with all these cores, all these cores, the hot water from top tank comes downward. It comes in contact with the cooling air. The heat from the hot water it dissipates to the surrounding or to the cooling air, and cool water is collected in the lower tank, from where it comes out through the this pipe, from where it is circulated to the engine, various parts of the engine through the water jackets. Next part is the upper tank and the lower tank are connected by means of a core. The hot water from the water jackets enter into the upper tank, and from where it flows to the lower tank through the core. The water is cooled down as it is divided into the thin string when it passes through the core of the radiator. The cold water is collected in the lower tank from where it is refilled to the water jackets. An overflow pipe is provided to the upper tank which allows the excess water to escape from the system. The radiator is generally made from copper and glass. So the material of the the material of the radiator is copper or glass, which is high heat conducting materials. Next part is various types of radiator. Next part is various types of radiator. First type is tabular radiator. In this radiator, when the upper tank and lower tank of the radiator are connected by series of tubes, by means of tubes, this is known as tabular radiator. Second is cellular radiator. In this type of radiator, it consists of large number of pressed metal sections soldered together to provide a continuous narrow passage through the core, that is known as cellular radiator. So this is the radiator. This is the tabular radiator. It consists of upper tank, lower tank, and between upper tank and lower tank, these are the cores which consist of tubes. These cores are in the form of tubes. So upper tank and lower tank are connected through the tubes or in the shape of tabular radiator. Next part is these are also are the different types of tabular radiator. In this first type, water is passed through these tubes and air is passed through these gaps. Water is passed through these tubes and air is passed through these gaps. These are the gaps which are provided for the air passage, and these are tubes which are provided for the water passage. Similarly, in second case, these sections are used for water passage and these spaces are provided for the air passage. So when air comes in contact with the hot water, it dissipates heat from the hot water, and hot water will be cooled down until it comes to the lower tank. This part is also this shape is also the tabular radiator. It consists of different tubes. These all are the tubes which, for water passage. Hot water is passed through these tubes and these fins are provided at the different sections, and air passes through these gaps. When the air passes through these gaps, the hot water comes in contact with the air, and air will remove the heat from this hot water, and up to when this hot water goes to the lower tank, it goes cooled. This is also the part of radiator. It consists of a pipe or tube. In this, hot water is passed to this tube, and these are the fins. When air comes in contact with this fins, it increases the surface area of the tube, so the cooling rate of the radiator is increased. This is also a type of radiator. In this, all these tubes are water tubes through which the hot water is entered, and these gaps are provided for the air gaps. Air is passed through these gaps. When air passes through these gaps, the hot water comes in contact with air, and heat is dissipated from hot water to the air. So this type, the hot water is converted into cold water. Next part is